Welcome back, Marauders. This video 16.5 will be talking about strong acids and strong bases. So strong acids and strong bases as well are ones that ionize completely. So there's 7 strong acids. You probably are familiar with these. You should know them. It's important to know the 7 strong acids, and then you'll just know that everything else that's not these 7 is a weak acid. And we'll go over weak acids in another video, in another section. Weak acids are a little more complicated because you have to deal with equilibrium, but the strong ones are pretty easy. No equilibrium is involved. The reactions go to completion. So what I mean by strong acids ionize completely is that however much acid you have, acids are proton donors. And so 100% of this acid is going to split apart and donate its proton to water. And at the end, you're going to have NO3 minus, and you're going to have H3O plus. Okay. There's not going to be any acid remaining at the end. It's all going to be donating its proton to the water. So whatever the concentration of the acid is, that'll be the concentration of hydronium in the end. We could have also written this out without the water. So we could have written it out as just HNO3 turns into H plus NO3 minus. So again, hydrogen ion, hydronium used kind of interchangeably. We can write the equation with or without water for a strong acid. The important thing here, really important thing, is that the arrow goes just one way. There's no equilibrium. None of these are going to come back together and make the reactant. So finding the pH of a strong acid is usually a pretty easy calculation because the hydronium concentration is equal to the concentration of the acid. Okay, they dissociate 100%, they completely ionize, they give away all their protons to the water, none of it is left as the acid, it all splits apart. So with HCl, for instance, we have HCl plus H2O, the reaction just goes in one direction, and it makes Cl minus and H3O plus because the proton is being donated from the HCl over here to the water. So if we want to find the pH, we know that however much HCl you have at the beginning is equal to the amount of H3O plus you have at the end, which in this problem is equal to 0.005 molar. And so we can find the pH by taking the negative log of the hydronium concentration, which is 0.005. And so the pH of this solution is going to be equal to 2.30. So really easy. It gives you the HCl concentration, but that really just means the concentration of hydronium because all of this is going to break apart. The chloride goes away, and that's your concentration of hydrogen ion. Strong bases are sort of similar. So strong bases also completely ionize, making the calculations of pH fairly easy. The strong bases are the alkali metal hydroxides and the heavier alkaline earth metal hydroxides. So starting with calcium and down the periodic table. So you should know these, and then any other base is a weak base, and we'll talk about weak bases later. So for strontium hydroxide, SrOH2, when that dissolves in water, it makes strontium ions, and it makes hydroxide ions. And it'll make 2 hydroxide ions. So for this question, what's the pH of a solution made by dissolving 1 gram of strontium hydroxide in 500 milliliters of water? All right, so first thing I need to do is take the 1 gram of strontium hydroxide, and we'll convert that into moles. So we use the molar mass of strontium hydroxide, add that up from the periodic table. It's 121.6 grams SrOH2 for every 1 mole SrOH2. Okay. There's no equilibrium involved here because it's a strong base. So 100% of it, however much you have, is going to completely go over here to the product side. So every time 1 mole of SrOH2 reacts, we're going to be making 2 moles of hydroxide. Okay, so we're going to be having 0.0164 moles of hydroxide in our solution. That solution is 500 milliliters of solution, so divide by 0.5 liters. So moles per liter gives us the molarity, and the molarity is of the hydroxide ion is 0.0328. 0.0328 molar for your hydroxide ion. Our goal is to find pH. Easiest way to do that when you have hydroxide is probably to find pOH. So pOH will take the negative log of the hydroxide concentration, which is 0.0328. And you'll find, when you do that on your calculator, that pOH is equal to 1.48. And then we know that pH plus pOH is equal to 14. So to find the pH, we can take 1.48 and subtract that from 14. When you do that, you find that the pH is equal to 12.51. Another way to do this, you could have taken the hydroxide concentration, used that to find hydronium, and then find the pH from that. You'll get the same answer either way.